In this lecture we will be discussing a few problems such as write and run a program which does something. In the exam you would be asked to write a program, or you would be asked to write a statement. If you are asked to write a program, that means you have to write the whole program using including the preprocessor directives such as include IOStream, and using namespace standard and integer main void, and in the end return 0, as well as some other functions as well if they are required. There could be some other problems such as you have to write some statement and that's it. I mean that would have lesser weightage, I mean 1 or 2 marks only. And in that scenario you would only need to write the statement only. But since I'm demonstrating how those statements actually work, I will be writing the whole program. But if you're asked to write a statement, that means you just need to write 1 or 2 lines of code, not the whole program. By whole program I mean the main function as well as the preprocessor directives, as well as the using any namespaces you might be. So let's go to our first problem. Write and run a program that prints the ASCII codes with the numeric codes for only 10 uppercase and lowercase vowels. Vowels are essentially English characters A-E-I-O-U, in which you need to place an N before that. So let's write a program over here, and I will just write the first line, and then I'll just copy paste the whole program, because each line is essentially doing the same thing. So I'm going to write the main thing which I'm going to write is which actually does the work is cout. I'm going to write integer and a, and this thing, I mean just a string over here. So I'm going to write, and then I'm going to convert it into the numeric value, which should be 65, and because capital A is 65, so and L, I mean this thing does the whole thing. So I mean this cout, I mean this is going to print 65 for that. So that's the main central idea of the program. So I will just copy paste the whole thing and write the overall structure of the program really quickly. Another thing which I've done is that I've actually saved all these questions which I'm going to discuss in this lecture with the appropriate file name with the extension of CPP. So it's not prompting me to save the file because I've already saved it before starting the lecture. So after running this code, it say that A, I mean carries the ASCII code 65, E is 69, and I is, I mean we have done the ASCII tables in the previous lecture. So this thing is actually self-explanatory because the characters are stored as numbers or as integers behind the scene, but since we are declaring them as characters or using them as characters, they actually display as characters. Okay, going quickly to the next problem. In the write 4 different C++ statements, each subtracting 1 from the integer variable. I mean there are many ways to do it, such as using pre-increment or post-increment operators, or it's actually is talking about the subtraction, so I can just use the pre-decrement or post-decrement operator, or I could just do the assignment operator. I mean there's so many ways to do it. I mean, let's say we have, I'm not writing the whole program, but it's understood that okay, let's write the whole program and just writing the from here. Let's copy this thing over here, and I'm just deleting this thing. So I mean, this thing is going to be in each of the problems over here. So let's declare a variable integer n equals to 0. Okay, I mean, I should not be using an uninitialized variable. I mean, whenever you are declaring it, make sure it has some value which you have assigned. So I can just do one of the statement could be n equals to n plus plus. I mean, I can just do that, or I can just write n plus plus, so that it will be incrementing the value of n. So I'm going to write cout value of n, and I'm going to have a new line over here. Then I could do sorry, it's about subtracting, so I should be writing, sorry about it, minus minus over here. So one more thing, I can do something like plus plus n over here. Sorry, I mean just minus minus n over here. So that means that would be decrementing this thing, so that will be cout n, and I'm going to print the value over here, even though it just asked the writing the for statement. So I mean, the correct answer is this thing and just this is statement. And I could do like n equals to n minus 1. That's also okay. I'm going to cout and n, and I'm going to write nl. This thing is actually using the assignment operator. So I can use a compound assignment as well. So compound assignment is n minus and n minus equals to 1. I mean, that essentially means this thing. So they mean this thing is means that n equals to n minus 1. Again, cout and nl, and let's run this thing. Since I've already saved it, it's not prompting me to save it again. So the initial value of n was 0, so I just did n minus minus. Since I mean, this thing is a post decrement, I mean, it will, I mean, since I'm not using this thing with some other expression, so it's just after running this line, the value of n would have been decremented. So the value of n is now minus 1. Then I did minus minus n. This is a pre-increment. It will just decrement the n, and then it will use it. But since no other operation is happening over here, so after running this statement, the value of n would be minus 2. Then I did n equals to n minus 1. So minus 2 minus 1 would be 3. And then I did n minus equals to 1. So the value of n previously was minus 3. So minus 3 minus 1 is now minus 4. So I mean, there's 4 ways to do it. I mean, essentially all of these 4 statements, this is statement, this is statement, and this is statement, and this is statement, they are doing essentially the same thing, decrementing n by 1. So one more thing is, if you're decrementing this thing by here, so it's actually decrementing only just by 1. If you want to decrement it by a bigger value, obviously you need to write a bigger number like minus 2, or maybe let's say you need to write minus 6 over here if you want to. So it's going to decrement n by 6. So it might be useful when we will be doing for loops or some loops statement where we have to jump the counter by a more than one value. So instead of using the increment or decrement operators, we might be using something like this statement. Let's say we need to decrement the counter 6 times in each iteration. So you might be using this, because these increment or decrement operators actually just decrement by just 1. Okay, so that's some simple example. In the exam, if you are just asked to write this statement, you need to write this line, this line, this line, let me correct it, and just this line. You do not need to write the whole program, because you just required to write the statement. Okay, in this problem, write a block of C++ code that has the same effect as the statement n equals to 100 plus m plus plus. Once again, I've written the overall structure of the program beforehand. I have saved the file. You need to write this thing again and again, even in the exam as well. So you need to write these lines, include iostream using namespace standard, integer main void return 0 in each of the program. If you're, I mean, here the block of code is being asked, so I mean, it depends. Really don't need to write the whole program, just need to write the whole code, which replaces this thing. So I mean this thing, let's say the value of m is 1, so this and value of n would be, after running the statement, value of n would be 101, because this is a post increment operator. So we need to remember that post increment operators, they work after the value has been used, so that if the value of m is 1, so that means 1 is added to 100 and the value would be 101, it would be assigned to n, and after running this statement, the value of m, which was 1, will be incremented to 2. So I mean we need to run the whole, I mean this thing, without it saying that, without using the post increment operator. So I can just do something like this. So let's say integer n, I mean need to initialize it beforehand. So and integer m equals to 1. It did not say what the value of m was before running this thing. It's just asking that write the block of code which does the same thing as this line. So what I'm going to do is I'm going to write n equals to 100 plus m, and then I'm going to write m equals to m plus 1, and that's it. So the value of n would have been used first and 1 would be added to 100, and then the value of m would be incremented. So after running these two lines, the value of n would be 101 and the value of m would be now 2. So it was, if it was 1 and now it was 2. So I mean in the exam you just need to write these two lines only. You do not need to write the whole program. Whenever you are asked to write a program to do something, you need to write the whole program, and whenever you are asked to write some kind of a statement or maybe a block of code, you just need to write the block of code. In this problem you need to, I mean similar problem to as we did here, but it's slightly different. It says write a block of C++ that has the same effect as the statement n equals to 100 plus m. So that means if the value of m is 1, okay, and so that means that 1 would be incremented first, it will become 2, and then that would be added to 100. So then the value of n would be 102. So what I need to do is I need to just declare a variable integer n equals to 0. I mean whenever you are using some integer, even though that's going to get some new value, make sure that you initialize it to some legal value, so that it does not contain any garbage value, just to be on the safe side. So m equals to 1, I mean it don't say what the value of m would be, so I'm just assuming it as 1. I mean you can just assume any value. So first I need to increment it. So first I'm going to do it m equals to m plus 1. I mean there's another way of doing it, m plus equals to 1. I mean that's exactly the same thing if I write this thing. So that means that this m is incremented first, and then n equals to 100 plus m. So that means the value of m would now be 2, and that 2 would be added to 100, and that would be 102 for the value of n. So it's asking for the block of code. You just need to write this line or maybe this line and this line, and that's it. You do not need to write the whole program, and that's it. So let's go to next example. Here it is being asked that write a single C++ statement. That's important. Single C++ statement. You need to write this one line that subtracts the sum of x and y from z and then increments y. And then increments y, that means it's obviously using some kind of a post increment operator. So I mean I need to declare the variables. Integer x equals to maybe some value, integer y equals to some value, maybe any value if you want to. I mean integer z equals to some value. If you know values are given, you could assume any values. I mean as long as they are legal values. So write a C++ statement that subtracts the sum of x plus y. So that means I need to write x plus y. So that's actually happening over here. So x plus y, and it subtracts from z. So if I write z equals to z minus this thing, that's also okay. Or I could just write z minus of all this thing. I could just write z equals to z minus equals to this thing. That's exactly means the same thing. And then it says after using all these values, it needs to increment y. So that means I can write the I know that after using the value I need to increment it. Since I'm only restricted to just one line, so I just write the post increment operator over here. If you're not happy with it, you can just write z equals to z minus this thing. That means exactly the same thing. Or if you want to make it more compact, I mean that's actually z equals to z minus this thing. That's actually one statement. Okay, so I mean I could just write z minus equals to, that means exactly the same thing. So I mean it does this thing, z minus equals to x plus y plus plus. It does, I mean it just adds x plus y, the sum of x plus y, and it subtracts it from z and updates the value of z and then increments y. So I mean it's not saying that you need to store the answer or to z. I mean I could have just another variable over here. I mean I could just have integer a equals to some value, and I could just write a equals to z minus this thing. So I mean it's not saying that I need to update the value of z over here, but it's up to you. I mean whether if you want to update the value of z and override the value of z, that's okay. The important thing is it says and then increments y, so that means the value of y is going to be used first, it's going to be added to x, and the whole thing z minus this thing will happen and will update the value of a. And after running this code, after running this line, the y plus plus would happen, the y of value of y would be incremented. In this problem, it says that write a single C++ statement. Once again, single is important, that decrements the value n and then adds. That means what's going to happen first? It has need to decrement the value n. So I need to use the pre-decrement operator and then adds it to total. So I can just update the value of total over here. So I can just write total plus equals to minus minus n, and that's it. I mean this thing equals to this thing. And if you want to have some space over here, you can just put a space over here, so make it more understandable. So total, I mean I could just write this thing as total equals to total plus minus minus n. I mean that would mean exactly the same thing. So make it more compact, I just write total plus equals to minus minus n. So it's decrements n first and then it adds up to total. Once again, since total and n are not declared, obviously need to integer n equals to 10, maybe some value total equals to 20. I mean need to declare the variables and then initialize them and before using them. But since it is asking just a statement, so I do not need to write these lines and maybe these lines and this line. I just need to write this line for the answer. In this program, in this example, I need to write and run a program that causes the negative overflow of a variable type short. So if you remember from the previous lectures, I mean we did include some file known as C limits, and if I just press Control and then this mouse pointer becomes a hand, I just click this thing, it opens the C limits header file. So if I can just go to limits.header file, so I can see that short minimum and short maximum, I mean it's an unsigned, I'm not talking about unsigned because it's asking for the negative overflow. So let's go back to this thing, negative overflow of type short. So that means I need to write the short variable. I need to declare something like short m equals to 0. I'm not using unsigned short. If I just write unsigned over here, that means it's only talking about the 0 and the positive numbers. I do not need to talk, I mean that means that if I overflow this thing, it's going to cycle it back to 0 and just rerun the whole number series again. But since we are talking about the negative overflow, we are talking about the signed number. So I do not even need to write signed identifier over here because this I mean signed keyword, not identifier is m over here. So signed keyword is understood to be there. I mean you don't need to write it over here. So short m equals to 0, we are not talking about the signed number. So this is a this is going to limits. So the minimum and maximum limits are minus 32768 to plus 32767. So obviously this thing is a let's try, I think it's a 2-byte number if I'm not wrong. So I mean we need to remember this. If you want to write it on your copy, I'm just going to close this file. I'm just also going to close this file. So I mean I can just quickly write the size of m and see what we get over here. I mean don't need to write handle, but just a practice. The size of m is in bytes, should be 2 bytes. So it's a 16-bit number. It goes from minus 32768 to plus 32767. So that means if I just keep on decrementing the value, I just need to write, I mean just cout and m equals to and the value of m, and L. I'm going to do it again and again so that you understand. So I just need to decrement it. Minus equals to like 10,000. So this is actually equals to M minus 10,000. I mean, that's exactly the same thing, just writing it in the short form. Then I just decrement it again. Now, I mean, let's see out this thing first. So see out value of the value of M is now equals to and M and L. So I'm not going to copy this thing. I just this is like should be minus 10,000, right? So 0 minus 10,000 is 10,000 because we are talking about the negative overflow. So let's copy these lines and indent it properly. That should now be like minus 20,000 and minus 30,000 and minus 40,000. So it should overflow right here because the limit was minus 32768. So let's run this thing, and it says the value of M should be like 0. Okay, 0 minus 10,000 and minus 20,000 and minus 30,000, and now it's going back to the positive value. So that means it's essentially going from the negative values and going all the way to, I mean, like minus 32768 and then 0 1 2 3 4 5 6 all the way to 25 5 3 6. So you can just count. Just make sure you also include 0 as a valid number if you are counting from minus 32768, and it cycles it back to 0 0 0 0 0, all 16 zeros, and then 1 0 1 0 and so on and so forth in the binary if you want to count it in binary. Okay, so going to the next example. Okay, in this problem, write a program that converts inches to centimeters. I mean, essentially a unit converter. So in the future, after doing the next topic of if-else statement, we would be or maybe a switch statement, we would be constructing some kind of a unit converter application in which we will be asking the user whether from which unit it wants to go to which unit. But say here it's just using the conversion from inches to centimeters. So I'm just going to ask the user that I mean, just going to declare a variable. It's pretty simple, float inches and centimeter, and see out. I'm going to write enter length in inches, and that's it. So I mean, I'm going to take the input from the user and the input operator. I'm going to assign whatever the user enters. It's going to be assigned. It's going to be assigned to be to inches, and then centimeter equals to what's this say over here? 1 inch equals to 2.54. Okay, 2.54 into inches. Okay, and see out, and I'm going to say inches have some here. Okay, inches equals to C. Okay, and then centimeters, and then centimeters. Okay, and then that's it, and L. Let's run this thing. It's going to 2.54 into inches. Oh, sorry, I did not. I still declared the cm over here, centimeters. I mean, it's cm. And the length in inches, let's say it's like 50. It says 50 inches is 127 centimeters. So you can just write anything you want over here, and that's it. And let's move on to the next problem. Here it says that write and run a program that demonstrates round of error by executing the following steps. A similar program was actually discussed in lecture 15. So it says initialize a variable of a of type float with a value of, I mean, that's going to do all these steps, and then initialize the variable b with type float with the value of this. So b should equal this thing, and initialize the variable c of this type, and c equals to this thing, and d should equal this thing. Print all 4 variables. We are going to see out the whole thing, and then show algebraically that d should equal a, or even though the computed value of d is not equal to a. I mean, this is caused by the round of error, because I mean, even if you are using the floating point precision, I mean, this thing is, I mean, it should not be I mean, D should be equal to A, but since floating point has finite precision, therefore it has a, I mean, some kind of a round of error, because it cannot store the complete fractions. We have demonstrated that so many times. So it says 1 2 3 4 5 6, so 6, okay, A equals to this 6, and float B equals to 1 minus 1 by A. So I mean, it's going to divide 1 by A and then subtract, because division has the higher precedence. I mean, if you're not happy with that, you can just use brackets if you want to, but it, since I mean, but it just does it because the division happens, division, multiplication, remainder actually happens first before addition and subtraction. So it says initialize part 3, initialize a variable C, float, and C equals to 1 divided by B, and then it says -1, okay, and initialize a variable of type float D, and D equals to 1 divided by C plus 1. So, and see out all these things. So I'm going to see out A equals to A and L, and I'm going to copy the whole thing. So value of B, sorry, C, D, and also need to change over here because that's the actual value being printed. So C and D, and let's run this thing and see what we get. So the value of A is 6666 and so on and so forth, and value of B is, look, we have a problem over here, 1 minus 1 or divided by 1 divided by this thing. I mean, it should get 0.1, or I mean 0.9999, and 1 by B is this, a very small number, and D equals to 645,279 over here. So I mean, going to demonstrate that, I mean, due to the round of error, I mean, this thing has now a big problem over here because due to the finite precision available. Let's see if we can get, if I just change a value, sorry, type to double, so would I get the round, because since I have the double precision, so I'm expecting a little bit less round of error over here. Here, since I'm expecting, I mean, it has a round of error, but I mean, it's rounding out to this thing. I mean, we are getting the same thing over here, but floating point is use 4 bytes and double has more than that. So I mean, if let's say if I can just reduce this thing, if I can just use long double over here, so I have even more precision. So I think it's double double or long double, I'm not so sure about it. Let's try that. So long double over here, and no, pretty much the same result as we had before. So, and let's try doing it in, I mean, and the last thing is show algebraically D equals to A, even though the computer. So I need to put up some paint application, and I'm going to draw it over there for the explanation. Before explaining, one more thing I need to explain is that double is probably, float was 4 bytes and double was 8 bytes. Long double, even if you do the size of operator, use the size of operator, you will see that it's a 16 byte number, but it's actually only 10 bytes are used. But due to some weird way how computers actually store the numbers and in some kind of blocks, they actually allocate 16 byte, even though they might be using 80 bits or 10 bytes. So I mean, we are not really sure whether it's an 80-bit number or a kind of a 10 byte number or a 16 byte number. So if you use size of A, you probably see the 16, not necessarily using all 16 bytes. So now going to the some paint application to understand how this thing is actually D should equal to A. Let's try explaining that. Value of A was 666 and 666. So I'm just assuming that, I mean, just a variable A, and this value A was, I mean, the B was 1 minus 1 over A, so I can just write A minus 1 over A, and then C was C equals to 1 over B minus 1, so I can just write 1 over this whole thing instead of B. So I'm going to write A minus 1 over A minus 1, so I can just write equals to A upon a minus 1 minus 1. So this thing equals to a minus a, I'm going to have a bracket, minus 1 over a minus 1. So this thing would be 1 over a minus 1. So this b equals to 1 over a minus 1. Sorry, this c, sorry, this c equals to 1 over a minus 1, and in the end d was equals to 1 over c plus 1. So I'm going to write 1 over a minus 1 plus 1. So this thing would be a minus 1 over 1 plus 1. This thing should equal to a minus 1 plus 1, and d should equal a algebraically, but due to floating point limited precision, we did not have the result as we expected because we used floating point. I mean, if you're using double precision, so yes, you could have nearly the same result. In this problem, we need to run the quadratic equation solver program, which we did in lecture 15, with the coefficient values of a equals to 2, b equals to 8.001, and c equals to 8.002, which demonstrated a round of error. So actually without now, instead of using floor, use double to see if there is any better performance due to double precision. So what I've done is, from lecture 15, I've copied the whole program which we discussed in lecture 15, which is essentially a quadratic equation solver which takes the values of a, b, and c. Just declare the values a, b, and c, enter values of a, and backslash t is just for the tab character. If you want to have some spaces, 8 spaces, and then it will display a equals to something, and then it will take the input and assign it to a, then it will take the input for b and assign it to b, and then it will see out for c, and then take the input assigned to c. So, and then it will just display the equation of a x squared plus bx plus c equals to 0. I mean, just to demonstrate that for the user that it has he or she has typed it in the coefficients correctly. Then we did the discriminant b squared minus 4ac, then we took the square root. For the square root, we need to include the cmath function, cmath header file, because sqrt is actually defined in this cmath header file here. Then we did the b squared minus 4ac over under root over 2a, and then and then minus b plus the under root b square minus 4ac over 2a, and then we did the other root. For the other root, we did minus b minus the square root of b square minus 4ac over 2a, and then we printed the solutions. And then we checked that we just put the values of x1 in ax square plus bx plus c to see whether that is actually equal to 0, and then we put the values of x2 in place of x in ax square plus bx plus c to check whether we have found the correct root. So just run this program, and I'm going to put the same values of 2, 8.001, and 8.002 over here. So if I run this program, enter the values, I mean, like 2, 8.001, 8.002. Oh, sorry, it's just due to the antivirus. Okay, 2, 8.001, and 8.002. It says, look, it's not equal to 0. So because it has a finite precision, so what I'm going to do is I'm going to replace float with double. I mean, I'm going to store all these variables in double type, and here double, and I mean, all of these things would be in doubles, and to see whether we have lesser error. So it's sorry, it's again this thing 2, 8.001, 8.002, and it has lesser error as before. I mean, it should display 0 over here. So I mean, if you want to go even better than that and use long double, it might be using 10 bytes or 16 bytes maybe, but I think I checked the specification. Long double is actually defined as 80 bits number, so that means it's a 10 byte number. It's stored at, due to some block issues, information is stored in blocks, so it might be stored as a 16 byte number, even though if it might have been using just 10 bytes of that storage. So let's see if we have okay, I mean, just due to antivirus. Okay, 2, 8.001, 8.002. Okay, lesser error. I mean, almost equal to 0, and this thing is almost this thing is equal to 0, but this thing has lesser error. So if you are going for higher and higher precision, yes, you need to, instead of using float, which is a 4 byte number, you might want to use a double or long double precision long double floating point number. In this last problem, we need to write and run a program to find which, if any, arithmetic operation can be applied to a variable, and that will change this value from any of the three numeric constants, infinity, minus infinity, and not a number, to something else. This applies to the actually floating point or double precision floating point exceptions whenever we have some number which exceeds the range of this floating point number. So if you go to this website, if you just look for this Wikipedia entry, single precision floating point, it says that it can store all the way from 3.4 to 10 to the power 38, and it lists the limits of these files, and it also contains the some arithmetic which we did in the previous lectures of floating point. So there's lots of good documentation over here. So what I'm going to do is I'm going to exceed the range. Let's say I've declared a variable float x equals to 1 into 10 to the power 30. So it has many zeros. 10 to the power 30 is lots of zeros. So I'm going to just multiply it by itself. So now it would contain 60 zeros, and then I just multiply it by -1. Obviously at this point it's obviously going to be exceeding the range of the floating point number, because just a floating 4-byte number, and keeping in mind that it's actually stored differently than the integers, so you might need to refer to the previous lecture. Then I just multiplied by -1, and then multiplied with again with -1. So obviously it's going from this number to infinity to minus infinity and back to plus infinity. This thing, I've written a note that changing a value from minus to plus infinity or vice versa is possible, but no arithmetic operation will change the value of the variable once it becomes not a number. Not a number happens when you just take a square root of a negative number. So that is a complex number, but here float and double precision point numbers actually expect a real number. So we are only dealing with real numbers right now. So I'm just going to remark this code. I need to explain it later on in a moment. So I've just typed it in earlier. So I'm just going to run this code only. So see what you're going to get. Here it says 1 into the power 30, and essentially like 30 zeros over here, and x being multiplied by itself. X is now infinity. It's a double. Sorry, it's float. It's not double. Then I multiplied by -1 itself, and it becomes minus infinity, and then I multiplied again with -1. It becomes plus infinity, and just is stuck over there. Now what I'm going to do is I'm going to, whether if I want to check whether something is a finite number or not a finite number. So I have written a condition. I'm going to explain it in the next lectures, inshallah, that what I mean by this thing, that it says that if it's less than or equal to FLT max and greater than FLT minimum. So that means that this thing is within these two numbers, FLT max and FLT minimum. So if you just include this float.header file, you will see that these are actually defined in the minimum, and the maximum are defined within that. So you need to search for it, or the better still, you can just look to this page over here, or the Wikipedia entry, to figure out what the actual maximum numbers are here. For FLT max and FLT minimum are these numbers. So you can just calculate them if you want to, or you can just refer to this website. This is a large website. So I'm probably going to share the link, or just copy the link in here. So let's go back to here, and oops, sorry. So I'm actually saw the large link over here. So in 2 lines, you might want to copy it again and again. So it's sorry, you just need to type it up, or if possible, I'm going to post it on the class comment. So it's available over there. So these FLT max and FLT minimum, if my x, the variable x, lies between this thing, that means it's a finite number. So it's going to say it's a finite number. Or I can, if whether you want to check whether after some calculations you want to check for some exceptions, that if the number has gone to infinity, if you're multiplying with some number, if you're adding some number, all the subsequent mathematical operations except for division with infinity are going to end up with infinity. If you divide by infinity, obviously you're going to get 0 over here. So if you want to check whether you haven't exceeded the range, so you can check with whether this number is within the limits. So this is a logical AND operator over here. I'm going to explain that in the next lecture, inshallah. So if x is less than this number and greater than minimum number, the maximum and minimum is storable in the floating point number, so we are going to see out a finite number. If this thing is true, this condition is true, this whole condition is true, it's going to see our finite number. Else if this condition is false, it's going to say not a finite number. So I'm going to remark these lines, and I'm going to explain that in a moment. So I'm going to run this code again, and it says that since x was infinity, it says it's not a finite number. So we need to check for that as well. I mean, if you exceeded the range, obviously it's not a finite number. And finally, if I'm just going to declare a variable float y equals to -2.0, and I'm just declared another variable initialized to square root of y. For a square root, I need to include the cmath header file over here. So that means that this y is a negative number, square root of it is a complex number. So z is going to be not a number, so any n. So I'm going to just run this code, see what happens. It says z is not a number, so that means it's a complex number. We are expecting a real number here. So and final thing is that if you want to check whether something is a complex number or not a number, you just check whether something is equal to that number. I mean, logically z should equal z, but it's not a number. This thing is going to put out false here. That's a special way to figure out whether some number is a complex number or not a number. So let's say if z equals to z, which it is, but then this line should run. If this condition is false, then this line should run. So let's see what line we run over here. So we have look, z is not a number. That means this condition is actually false, even though it, I mean, had z been a normal number like 4 or maybe 5, and you just compare 5 equals to 5, that means that is true. This line should have run. But since we are dealing with not a number, so that is saying that this condition is now false, then else is actually running. We are going to explain how these conditions are actually made in the next lecture. And finally, one last thing which I did not write over here. Let's say I just see out one thing. Let's say I'm dividing 2 divided by x. So obviously I'm going to get a 0 over here, because dividing by infinity is 0. So let's check it out over here. This thing should equal 0 over here. That's over here. So c out 2 divided by infinity is 0. So I mean, you need to check whether some numbers, if you are computing if you're doing some computation, you need to check whether some numbers are I mean, if they are exceeding the range in which they could be stored, either use a bigger type such as double or long double, or if you want to check between them that they have exceeded the range, we have explained how it's done over here, so that your subsequent calculations do not contain 0 or not a number. Quick summary of this lecture: we did the problems of relating to the previous lectures after, I think, lecture 7 to lecture 16, and we did about quite a few problems. So let's go through them really quickly. And first we did the how to convert the the characters to their in numeric values. Then we did the 4 different statements to subtract one or any condition. The important thing is, if you are just asked to write a statement or block of code, just write block of code or the statements required. And if you are asked to write the whole program, you can write the whole program, including main function, any other function, and including the header files, and using the standard namespace. And then block of code to do some tasks as post increment and pre-increment operators. Then we did the single statement, and that was quite technical over here, but if you can read the statement carefully, you can do it. Then we did the same thing over here. I mean, if you just watch out for this keyword then adds to it, and you cannot figure out if you want to use a pre-increment or the post operator or the pre-operator. Then we did the demonstration of the negative overflow of type short. We could also have demonstrated with long and integer type as well. And then simple conversion. We are going to revisit the program after doing the switch cases statement, in which we will be asking from the user what units that user wants to convert to which unit. A similar application is available in our mobile phone. So we are going to make a simple command line based application based on that, using the same logic. I mean, if the user has pressed lengths inches to centimeters or feet to feet to inches and so on and so forth. I mean, we could have just different, for the different cases we might input different conversion factors and multiply them based on the user choice. Then we demonstrated the round of errors in this floating point because it has a finite precision. And then we did the quadratic formula, same thing. Instead of using float, we did use double, and in the end we did the not a number and infinity and minus infinity discussion. A small thing which I forgot to mention when I was discussing this problem, that write and run a program that causes a negative overflow variable type short. I said that this variable is of 16 bits. How I figured that out, that I saw the range of this variable, it goes from -3 to 768 to +3 to 767. So if I just subtract this number from this number, I will get 65535. But since I'm also including 0, because I need to figure out what range or how many numbers are there from -3 to 768 to +3 to 767 including 0, so I will get 65536. So if I'm just including 0 as well, so if I want to figure out how many bits I need to have to represent these many numbers, so I just take log 2 base 2 of 65536, I will get 16. So that means I need 16 bits to represent a number or represent a number from anywhere from -3 to 768 to +3 to 767. Or if I'm going from 0 to 65535, it's still 65536 numbers. I still need 16 bits for a unsigned short number. If you cannot do log 2, I think, but the calculators do have the facility to compute log of any base. But anyway, if you can just take log 10 of 65536 divided by log 10 of 2, you would still get the same number over which we have over here.